All right, what's up, crew? This is one of the most famous geometry lessons of them all, and that is the sum of the angles in any polygon. So we proved earlier, actually, why the sum of the angles of a triangle was 180. So you have to kind of know that. That's our starting point. That would be our postulate, that the sum of the three interior angles of a triangle is equal to 180 degrees. Well, from there you can get any shape. So here's some random quadrilateral. I know it looks like a parallelogram, but it could be anything. If I divide it into non-overlapping triangles, I can create two triangles of that. So this is 2 times 180, which is 360. Okay. What if I have a 5-sided figure? Well, I could start at 1, and I could go to this. Oh, that's a 4-sided figure. Jeez, beasties. What if I had 1, 2, 3, 4, 5? I could start there, and I could go to this point, and I could go to this point, and now I've got 1, 2, 3 triangles, and 3 times 180 is 540 degrees, and that's how many are in a pentagon. And guess how many are in a hexagon? You got it. Oh my gosh, I just can't count. Struggle of a day for me. But I'm not even going to do a remix. Some random hexagon. Think about it. It's not going to form a triangle with the two vertices that are right next to it, but all of the rest of the vertices will form non-overlapping triangles. So the number of non-overlapping triangles is equal to 2 less than the number of vertices. So this would be 4 times 180, which is indeed 720 for a hexagon. So hopefully you've now deduced that the sum of the angles in an n-gon, the interior angles in an n-gon is n minus 2 times 180. Okay? I'm sure that's what this is going to show you. Boink. Boink. This is what I just did. Boink. Oh, what do we got down here? Oh, so yeah, go nuts on these. Play around. Okay, please. You learn so much by playing in life. I don't know. Let's see. What do you want me to do here? One triangle. What if I said, what do you want me to do? Oh, number of sides. Can I change that? Uh-oh. Hold on a sec. Yeah. Oh, I can do a slider mode. So if we have 10 sides, we have 8 triangles. We have 5 sides, we have 3 triangles. Okay, this is pretty much what I just did for you, but now you can slide it around. Have fun with me. Okay, here we go. This is what I just showed you. All right, now, the measure of an interior angle of a regular n-gon. Okay, so this is like really important. Maybe obvious, but if not, if this is the sum of the angles, and if it's regular, what does that mean? Well, all of the sides are the same, and all of the angles are the same. So if it's a regular n-gon, to find the measure of each side, of each angle, you just divide by n, the number of angles. So look, a regular pentagon has 108 degrees. 540 divided by 5. Let's view an interactive one instead. Can't wait for this. Oh yeah, sliders. 180 times 11 divided by 13 152.31. 150 for a dodecagon. Decagon, 144. My favorite shape of all of them, that regular hexagon, 120. Okay, now the sum of the exterior angles is totally different. It's always 180 if we consider one angle at each vertex. So this is kind of strange to imagine, but like if you extended every side of a polygon in only one direction, and then you added up all of the exterior angles formed. Look, what if I did a triangle? Let's say this was an equilateral triangle. It doesn't matter because it's going to add up to 180. So if we extended that in one direction, you got 120 here, you got 120 here, you got 120 here. That's 360. What if we did a square? 90, 90, 90, 90, 360. Hexagon, 360. All of them are 360. So I bet that's going to lead us to, our next theorem, which is the exterior angle sum. There it is. The measure of the exterior angles of a convex polygon, one at each vertex, is 360. And now you guys will be kind of practicing. I think that's probably enough to get you started. Here's your summary. Theorem 6.1, Theorem 6.2. Boom!